Hi gents, this is conditions of equilibrium and we're having a look at that exercise 1 again, which we've just done. But this one we're doing the graphical version of it, okay? Now, it's up to you whether you do mathematical or graphical first. It's your personal choice. My personal choice is to do mathematical first, so at least I have an idea of what those the answers are, what the figures are that we're aiming for. But if you like to do graphical first, that's fine, and let's have a little crack. So we've got our drawing, okay? Now we've done our free body diagram, which we did before, and we have a little bit of an idea on what that triangle should be looking like, okay? Arrow directions, and we want to have a go at drawing that. So it's basically, we're drawing this to a neater scale, basically. So we know that 500 Newton arrow goes down. Yeah, that's our first one. So we're sort of going to start with that. I'm going to do it towards the bottom of this page. The first step you should always do for this. So we know that we have definitely one force of 500 newtons on our drawing. The first thing you should always do is set a scale. Now that scale is depending on that figure, or if there's two figures, those two figures. Now that's quite a large figure of 500. So for this one, I would actually probably give a scale of maybe 1 mil equals 5 newtons. Now that scale is going to change depending on student to student and on even size of how much force is getting pressed down. For example, if that was 10 newtons, okay, you're probably not going to go 1 mil is to 5 newtons, because you're going to have a tiny little triangle drawn. So you want to make sure the triangle is a nice, good, decent size, so the marker can read it. So you got scale 1 mil is to 5 newtons. So we're basically saying that 500 newtons, we know straight away 1 mil is to 5 newtons. We know that is going to be at 100 mil. Okay, long. So that's a decent size drawing. So if we have a look at this, okay, we're looking at from basically that point down to there, which is 100 millimeters. So let's have a go. Let's do our first part. So the first thing we should do is at least just get a part so we can a 90-degree angle, so we can at least start. So we'll start from there. Now this doesn't matter how long this is. Okay, I'm just going to draw that a nice straight line. We get our protractor out, which we had before, okay. Now the whole point of this one is, we're setting this up on the 90 degrees, dead set on the 90 degrees, so at least we can have a little bit of a start here. Okay, we're going to draw that in. Okay, it's good. And you're just extending that line across. So remember, when you're doing this graphical version, you want to make sure you're as accurate as possible. The more accurate you are, the closer you'll get to your answer. Okay, so we draw that across, right? So now we've at least got a starting point there. Now from that starting point, now I've done the mathematical, so we know that's how, in that section there, we're 288.7 newtons, but you might not know that. So I would start a fair way along, okay? I would start, let's say, I'd probably start all the way over here, okay, on that 12. So we grab our protractor again. Now we know in here we've got a 90-degree angle. So we place that protractor on there, right on that point somewhere. Okay, where that 90 degrees is, just push a little dot. The most accurate you can be, the better. Okay, you're lining up those 2 points, right? 2 points, and you're drawing that in. Okay. Now that's going to be our 500 mil line. So we know that has to be 100 mil directly. So I'll measure that. Okay, directly on 100 mil. Right. Place a little mark there so I know where to stop. Okay, there we go. And we can add in our arrow for our first one. Okay, so that's 500 newtons on that. And we know 500 newtons is equal to 100 mil. Based on our scale. Okay. Now, our next bit gets a bit more trickier. So we know up here we have a 30-degree angle. and that's our most accurate line so far, so we probably want to work off that. So we want to turn our page around, placing our mark of our protractor on there. There we go. We want to line up that 30 degrees, so we want to place what do we got? A little mark in here. Okay, remember, as accurate as you can be. Right, so 30-degree line there. Grab our rule, and you want to line up those 2 points as best you can. It's a little bit tricky. There we go, it's pretty close. Draw that down. Okay, there we go. So now we got this. So we're saying up here should be 30 degrees. That should be 60 degrees in that corner. Just bring this up so you can see it. There we go. So 30 up here, 60 down here, 90 in the corner. Now let's have a little measure and see how close we got, because we've done it mathematically, so we have a very good idea of what the size should be. So we have a look. Okay, so this is drawn there as close as I can. It basically says 58 millimeters. Okay, and if we put that into our calculator, 58 multiplied by 5, because we use 5 newtons. Okay, 58 multiplied by 5 gives us 290 newtons, basically. Okay, so we said before it's 288.7 newtons, so that's pretty close, so that's not too bad. So let's have a look at the next bit. What's this next one say? It's right on 115. So if we got 115 multiplied by 5, 15 multiplied by 5 gives us 575 newtons. Okay, and that was number 2 there, and that was number 1. Okay, so we can see number 2, 577.4. Okay, that's pretty good too. So gents, that's your first one doing it graphically. Probably just add these in, these degrees in the corners. Okay, what I want you to do is have a go at exercise 2 and 3 graphically and mathematically. And as you can see, mathematically you'll get the exact answer. Graphically, you will get very close, within 1 or 2 newtons. That's what you're aiming for. Okay, so have a go.